All right, Algebra 1B students, welcome to part 2 of lesson 8.6 on our factoring of complex quadratics. We are going to apply today our diamond problems from yesterday and our generic rectangles to factor a quadratic that's a little bit more complicated. First, I want to review what generic rectangles look like. So we're going to look at these two one-off problems here. And we're going to use generic rectangles to simplify them instead of using FOIL as we have been doing in the past. So for number 1, I will make a generic rectangle here. And along the left side, I will put my first binomial, which is 2x and a positive 8. And then along the top, I will put my second, which is an x and a positive 2. Now in the generic rectangle, I'm going to multiply each length and width to find what goes in that box. I know for the top left box, 2x times x will give me 2x squared. Top right box should be 2x times 2, which will give me 4x. Bottom left is 8 times x, which gives me 8x. And bottom right gives me 8 times 2, which is 16. Now I'll add all those together, combining the like terms here in the bottom left and top right, which will give me 2x squared, and then 8x plus 4x gives me 12x plus 16. All right. Now I would like you to look at the second one. So pause the video, take a look at that second warm-up problem. Use a generic rectangle to simplify that into this type of quadratic here. So pause the video, take a look at number 2, start it again, and I will show you that answer so you can check your work. Okay, our generic rectangle, if I put it down here now, along the left side I'm going to put my first binomial, which is x and a negative 3, x minus 3, and across the top will be my second, which will be 3x and a minus 7. Now in my top left box I see x times 3x, which will give me 3x squared. In my top right box I see an x and a minus 7, which is minus 7x. My bottom left box is negative 3 and 3x, which gives me minus 9x. And finally, my bottom right is negative 3 times negative 7, which is a plus 21. If I put all of those together, my final answer is 3x squared minus 10x plus 21. Now, one thing I want to remind you of before we move on is that in all of these generic rectangles, if I multiply the top left and bottom right boxes, here for example, 2x squared times 16, that is exactly equal to the bottom left and the top right box, 8x times 4x. Both of these end up being 32x squared. 32x squared. That's going to be very important for us. Okay. The bottom left, top right, top left, bottom right multiplication rule is going to be important for us factoring quadratics today. So that's what we're going to look at now. How do I go backwards? We are going to use a generic rectangle to factor 3x squared minus 16x plus 21. Which I am realizing is actually what this should be up here. Minus 7x and minus 9x is minus 16x, not minus 10x. I apologize for that. Hopefully we can take our quadratic here, 3x squared minus 16x plus 21, go backwards and end up at that warm-up problem. That's going to be our goal. Okay? I am going to list steps for you and walk you through that example problem. Tomorrow I will expect to see these steps in your notes, and I will expect to see the practice problems at the end in your notes finished and completed as well. Okay? Step 1 to using this generic rectangle to factor 3x squared minus 16x plus 21. Step 1, put 3x squared in the top left square. 3x squared in the top left square. And put 21 in the bottom right square. Okay? Because we know that here and here we should end up with numbers that multiply to be 21. And then here and here we should end up with numbers that multiply to be 3x squared. So we'll put those in exactly where they are. The other reason we can do that is because we know that that's the only x squared is in my top left box, right? And the only numbers are in my bottom right box. This box and this box both have x numbers in them, which we're going to try to find here in a minute. Step 1 is to put 3x squared in the top left box, 21 in the bottom right box. Step 2, multiply 3x squared and 21 so that you know what the other two boxes multiply to equal. Why does that work? Because of our rule that the top left and bottom right boxes multiplied together has to equal the bottom left and top right boxes multiplied together. So, what is 3x squared times 21? That is 63x squared. So I know that whatever goes in this box and this box, they have to multiply together to give me 63x squared. Now, we're going to use our diamond problems to find what those two missing pieces are in our bottom left and top right box. I know that they have to multiply to be 63x squared. And I know from my original problem, if I scroll back up, that they have to add to be negative 16x. Because these two boxes, here and here, should contain my two x numbers that need to add to negative 16x. So we'll solve this diamond problem to find the two terms that multiply to be 63x squared and add to negative 16x. Okay. Now, multiplying to be 63, adding to be negative 16, I think both of them need to be negative, so that they add to a negative but multiply to a positive. So I know they'll both be negative, and factors of 63 would be, let's see, 1 and 63 won't work. 3 and 21 won't work. 7 and 9, that will work. 7 and 9. Both of them need to be x's so that I get x times x is x squared up here, and x down here with my 16 as well. So my two missing terms then are 7x, negative 7x, and negative 9x. Okay, so we use our diamond problem to find those two missing boxes. Then we put those two missing boxes back in. 3x squared, 21, and now I have filled in negative 7x there and negative 9x there. And my last step, which is very, very important, is find the greatest common factor of each row and column. So what that means is I'm going to look at this column right here, 3x squared and negative 7x, and find what is common between the two. I don't think 3 and 7 have any factors in common because they're both numbers that are just 1 in that number. There's no other factors. So the only thing that's common here is an x. But if I look at this column, I notice that the x is not common because the 21 here is missing an x. It's not there. So we can't say x is the greatest common factor or part of our greatest common factor. But what I can say is that 3 is somehow involved here, correct? 3 is somehow involved. So I am going to take out a 3, and because one of them is negative and the other is positive, I'm going to take out a negative 3 there. Okay? A negative 3. 9 is 3 times 3, and 21 is 7 times 3. That's why I pulled out the 3, just so we know where that factor is coming from. Now, if I look then at this row across here, my top row, I have 3x squared and negative 9x. I do see an x that is common, so I know there's going to be an x involved here, because there's one of them with my 9, and there are actually two of them with my 3. So one of them is common to both boxes. And then if I look at my numbers, it's 3x squared and negative 9x. 3x squared and negative 9x. I know a 3 is going to be involved somehow, so I will take out a 3x, because 3 is 1 times 3 and 9 is 3 times 3, so a 3 is common. My question then is, should I make this negative? And to answer that question, I'm going to put, I'm going to do my multiplying here. 3x times x, meaning this number here, 3x times by x. I need that to be equal to what is in this top left box. 3x times x does give me 3x squared. There's no negative sign in here, so there's going to be no negative sign out here. So I'm just leaving it as 3x so that I can still have my 3x squared in my top left box. Okay. In fact, I will tell you that this term here and this term here will not be negative for any of our purposes. Okay? There will always be these terms here, this one and potentially this one will also be negative. Now I'm looking as my final row here, my bottom row, negative 7x and 21. I need to find the greatest common factor of those two terms, negative 7x and 21. I notice that again there's not an x on my 21, so x is not common here. But I do know that 7 is 1 times 7, and 21 is 3 times 7. So a 7 is common to both. I'll take out a 7. And again, I'll ask the question, should that be negative? Well, I want my negative to show up in here with my negative 7x. And since up here, that is not negative, that's a positive x, I need a negative 7 to do negative 7 times x, giving me negative 7x. Okay? So both of those should be negative. Both of your constant terms should be negative. Negative 3 and negative 7. Once I have finished pulling out my greatest common factors, I am essentially done factoring that quadratic. I just have to sort of piece this all together. If I look across the top, I have x and I have a negative 3. I'm going to put those together to be x minus 3. And if I look down the side, I have a 3x and a negative 7, so I'll put those together as well. And there is my factored form. I'm going to go through one more example with you and then give you one problem for you to do on your own. Please write down this example with me. Factoring this expression here, 5x squared plus 11x plus 2. I'm going to go back through my 4 steps with this problem, then give you one to do on your own. I'm going to set up a generic rectangle right over here. And as I go, I'm going to fill in certain pieces. Okay. I know step 1 says to put my 5x squared here and to put my 2 down here. My next job is to find this missing square and this missing square. And for that, I will use the diamond problem. I need 2 numbers that add to be 11x. And my next question is, what do they need to multiply to be? Well, step 2 said to multiply 5x squared and 2 to figure that out. So 5x squared times by 2 equals 10x squared. So I need these 2 terms to multiply to be 10x squared. 2 numbers that multiply to be 10x squared and add to be 11x. Well, things that multiply to be 10 would be 1 and 10. Good news here, that already works out. 1 and 10 add up to be 11 and multiply to be 10. I just need to make sure I have an x on both. So now my two missing boxes of my generic rectangle, if I go back over here, 1x and 10x. Yes? Now the only other thing I need to do, step 4 said to find the greatest common factor of each row and column. So that is what I'm going to do. If I look first at this row here, I see 5x squared and 10x. And x is definitely common. And I think there's a 5 as well, because this is 5 is 5 times 1, and 10 is 5 times 2. So I'm going to pull out a 5 and an x because I know they're in both. Then if I look at my bottom row, a 1x and a 2. The x is not common because there is not one in the 2 box. And 1, the only factor of that is 1, so it must be 1 as my greatest common factor. If I look at this column here and go up, 1x and 5x squared. Again, my number is 1, so the only factor that has is 1. So I know this is going to be a 1. But I do see an x that's common in both. 1x. There's one of them here, and there's 2 of them right there. So I know 1 is common, so I'll have 1x as my greatest common factor there. And finally, this column here, if I go up, I'm finding the greatest common factor of 2 and 10x. I do not see an x that's common. I don't see any negative signs anywhere in here. But I do know that 2 is 2 times 1 and 10 is 2 times 5, so a 2 is common there. I will finish off this problem by writing those 2 factors from my left side, 5x and a positive 1, and to the top of my generic rectangle, 1x and a positive 2. That is my factored form. I'm done. The only thing that I need you to do before you are all ready for your practice problem set tomorrow is to use factoring and generic rectangles and diamond problems to factor this expression and find me the possible dimensions of that rectangle. So factor this expression. There will be some negative signs involved here. And find for me the possible dimensions of that rectangle. Once you've mastered that, you're ready for your practice problem set tomorrow. If you have questions, please make a note to ask me in class tomorrow. That's all I have for you right now. Pause the video, take a look at this problem. I will keep the video going long enough to show you the correct answer there, so you can check your work. But otherwise, this is it. We're ready to factor some serious quadratics through our box and diamond process. Pause the video, take a look here, come back, and we'll see the answer, and that'll be all I have. Okay. The correct answer here, 2x and x, and my missing pieces are 7 and 1. I need a minus 7 and a plus 1. 2x plus 1, x minus 7. That is the correct answer there. Possible dimensions. 2x plus 1, x minus 7. All right, that's all I have for you. If you have questions, please ask me in class tomorrow. Otherwise, have a great night.